Welcome to all. So in this, we'll solve a question from previous year GATE question paper in chemical reaction engineering. This is from chemical reaction engineering CRE question paper of year 2021. In the last lecture, we have solved two questions from the same paper. The link for that is given above. Now we will see one more question. Well, this question is question number 51. The following homogeneous irreversible reaction involving ideal gases. A gives B plus C. The rate expression is given. We can see from this the rate expression is first order. Is carried out in a steady state ideal plug flow reactor PFR operating at isothermal and isobaric conditions because it's a gases isobaric constant pressure. The feed stream consists of pure A entering at 2 meters per second. In order to achieve 50% conversion of A, the required length of PFR is how much? Length of the PFR is asked. What is given is entering velocity, linear velocity is given. Well, this is a PFR equation. PFR, the reactor is PFR. So this is a PFR equation, tau by C naught equal to integral dxa by minus RA. And it is the first order, so minus RA equal to KCA. And it is a gas phase reaction, right? Gas phase reaction involving change in number of moles. A gives B plus C. So therefore it is a variable volume reaction. So for first order variable volume reaction taking place in a PFR, what will be this integration? You should be able to remember this integral equation of this form. We can integrate this, but in the GATE exam, you cannot afford to do the integration. It will be 3-4 steps. So it will be better if you remember the final equation of this. Final equation of this integration. Anyway, here, for the sake of understanding, I will do the integration and you will see the final equation. Now for CA, you have to substitute in terms of XA. For variable volume reaction, CA is CA naught into 1 minus XA divided by 1 plus epsilon A XA. That is important. You have to substitute CA as CA naught into 1 minus XA by 1 plus epsilon A XA. So for variable volume reaction. So if you substitute only CA equal to CA naught 1 minus XA, it will be wrong. For variable volume reaction, CA is this. So let me substitute. XAF is the final conversion. So if we simplify this, is equal to tau by CA, right? Now how do we integrate this? Now this term 1 plus epsilon A XA by 1 minus XA. If you split this into partial fractions, say A plus B by 1 minus XA, you will find A is minus epsilon A and B is 1 plus epsilon A. That means this term can be split into minus epsilon A plus 1 plus epsilon A by 1 minus XA. So I will substitute this here. I will substitute it here. For this, 1 plus epsilon A by 1 minus XA. I will substitute this, right? And also this case CA naught and CA naught will cancel. So let me write tau equal to integral minus epsilon A plus 1 plus epsilon A by 1 minus XA into dxa from the limit 0 to XAF, right? If we integrate this, it is minus epsilon A. Yeah, there is K here, okay? There will be K here. Only C and naught is cancelled. There will be K. So 1 by K epsilon A into XA minus is going to be the integration of second term is ln ln between the limits 0 to XAF. So this is the integration of this. Now if we substitute the limits, you get tau equal to 1 by K upper limit minus epsilon A XAF minus 1 plus epsilon A into ln 1 minus XAF. The lower limit, when you substitute 0, both the terms will be 0 at the lower limits. Both the term will be 0 at the lower limits. So this is your final integral equation. For a first order gas phase reaction or a variable volume reaction, for a first order variable volume reaction taking place in a PFR, plug flow reactor, the final integral equation is this tau equal to 1 by K into, both the terms are minus epsilon A XAF minus 1 plus epsilon A into ln 1 minus XAF. Now let us substitute the values. All values are given directly. K is given as K is 0.5. Initial concentration is not given, but conversion is given. Conversion is 50%, 0.5%. K is 0.5. These are the given values. K equal to 0.5. K equal to 0.5. And XAF also is equal to 0.5, 50% conversion. And what about epsilon A? Here if you see, the reaction is A gives B plus C, and there is pure A in the feed is given. There is pure A in the feed containing pure A. The feed stream consists of pure A. Pure A. For such cases where you have only one reactant and pure A is entering, epsilon A can be simply found by delta N by A. So delta N is the difference in stoichiometric coefficients, product minus reactants. So here one stoichiometric coefficient is 1 here, 1 here. Product side 1 plus 1, 2, and reactant side only 1. Coefficient is 1, 2 minus 1. A is the stoichiometric coefficient of reactant A, that is also 1. So epsilon A is 1. So epsilon A is 1, XAF is 0.5, K is 0.5. If you substitute all this in the integral equation here, you substitute all in this, substitute all these values, substitute the numerical values, you will get, substitute and simplify, you will get tau equal to 1.773, right? And what is tau? Tau is actually V by V naught. Tau means what? Volume by volumetric flow rate. By basic definition, volume by volumetric flow rate. But what is required here is the length of the reactor. So this V by V naught can also be considered as length of the reactor, L for length, and linear velocity. Good question. What is given is linear velocity. So let me call the linear velocity as VL. So this is the length of the reactor, and this is linear velocity. Which is given as 2. Linear velocity is given as 2 meter per second. So V by V naught, the ratio of V by V naught, is the same as the ratio L by VL naught, that is the length by linear velocity. Linear velocity is given as 2. Linear velocity is given as 2 meter per second. 2 meter per second. So the length of the reactor will be, linear velocity is 2, isn't it? Yeah, 2. So length of the reactor is going to be how much? 2 into 1.773. 2 into 1.773. That is equal to 3.545. This is in meter. The question is, you have to give two decimals in meter. So the answer will be 3.2 decimals. Correct to two decimals is 3.55 in meter. So this is the answer. So answer to the question, what you have to fill up here is length of the PFR. Length of the PFR. The length of the PFR in meter up to 2 decimal places is 3.55. Is 3.5. So this is sorry, here it is not. This is not tau. This must be not tau. This must be, when you multiply by L, it becomes, when you multiply by the linear velocity, it becomes length. Wait a minute. Length. This is L. L stands for length of the reactor. Well, so these are the 3 questions. One question is solved now, question number 51, and previously in the previous lecture we have solved question number 49 and 50. The simple questions, straightforward questions. They had asked both from constant volume as well as variable volume reactions. They had asked in mixed flow as well as plug flow questions. Well, we'll come up with more solution. We'll come up with more solutions for gate questions in the next lectures. Please stand by this, and I also request you to please subscribe to this channel, and please share it to your friends. Please hit the subscribe button. I find that most of you who are watching this are not subscribers. Request you to please subscribe to this channel. Thank you and bye.